Okay guys, this is my first attempt at a review, video review of our AP Physics course. And what we're going to do is I am going to do one on one-dimensional motion, which is what you have your quest assignment on right now. Okay, so let's go over a couple of terms here. First of all, position. Position is basically where you are, and we're going to usually use an X, the variable X for that. Other books use other things. Now, in position, we're always going to think about where we are in reference to some starting point. So it's basically a coordinate system, and we're usually going to designate 0 someplace as 0. And to the right, we're going to make it positive, and to the left, we're going to make negative. So if you're over here, let's call that position of -3. I don't care about units right now. Just tells me I'm to the left of the 0. Again, plus and minus, basically all that tells us is direction. Alright, doing my best that I can with these new tools that I have. Obviously, if you have something over here, say +2, I am 2 units to the right of wherever I designated my 0 to be. Again, we're going to use X for that. Okay, so position, put a little check mark by position. Alright, displacement. Displacement is your change in your position. Anytime we see this delta, I'm going to go down here. Anytime we see this delta, remember, that signifies we're going to subtract. Okay, we're going to subtract. You guys know I can't spell. And basically it also means that we're going to take our final position and we're going to subtract our initial position, and this position right here, or either one of them as a matter of fact, could be positive or negative. Okay, so if we look at this example right here, let's make this our final position right here. Alright, we'll go make this our final position, and I'll make this our initial position. Okay, let me hit my little erase button here. Okay, go back to my pen. There we go, and make that an I right there. Alright, got it. So my displacement, my change in position would be, again, final minus initial. My final was a +2, and I'm going to subtract from my initial position, which is a -3. Okay, it's not a very good plus sign right there. So what I end up getting is my change in my position, or my displacement, being a +5. Okay, so displacement, change in position, covered. Distance is the absolute distance that I travel. So for example, if I were to start, let me erase a little bit of this for just a second. Okay, if I were to start, let's say here. Okay, start here. If I were to start here again, go to -2 and travel back to 0 right here. Okay, the distance I would have traveled would have been 5 plus 2, so I would have traveled a distance of 7 units, and let's just say they're meters, could be miles, so 5 and 2. Distance is always positive. Okay, however, the change in my position, my final position is 0, my initial position was 3, so my displacement would have been +3, because I was moving to the right. That also brings up another sort of issue here. Displacement is a vector. Direction matters. The +3 tells me that I was moving to the right. Okay, distance doesn't care. Distance doesn't care. So again, this is a review. You should remember this. All right. So Put a little check mark by distance, covered distance. Okay. Next, velocity. So velocity. Velocity, very simple definition, and it's simply, and all you guys I'm sure remember this, that velocity equals, okay, your change in your position, your displacement, over your time. And I'm going to put change in time. Most of the time we drop that this triangle right here. So now this is also, now I'm going to put a little bar here. This is defined as basically your average, your average velocity. And for the first part, we'll always be talking about constant velocity anyway. Okay, let's keep going here. All right. So, and velocity, because the displacement is a vector, velocity is a vector as well. Okay. Speed, on the other hand, is not. Speed is, it can be one of two things. It can be, and we'll use an S for speed. It can be your total distance over your total time, or it can simply be the absolute value of your velocity. Okay, I'm going to come back and talk about these two in a minute. And the acceleration is also, and I'm sure you folks remember this, speed. Your acceleration is defined as your change in your velocity over change in your time. Vector, vector, vector. Displacement, velocity, and acceleration are all vectors. Speed is only a positive number. It is a scalar, and so is distance as well. Okay, let me get rid of this layer and let me go to this guy. Oh, yes. So what would these look like if they were graphed? I'm going to assume for all of these examples that we're going to move at constant velocity. We're not going to change velocity, okay? So the acceleration here will probably end up being 0. So if I were simply to walk away from the origin, oh, turn this on. That's not good. Which layer is this? That's not good. Oh, I see what I did wrong. Okay. So if we're moving away to the right, like that, I'm moving away at a steady pace. Okay, and again, because this is going, we're going up here, so this is a positive. We're moving away from the origin, and we're moving at a steady rate. So we're moving to the right because the numbers 1, 2, 3, 4, 5 are increasing. They're not becoming negative. All right. Now, what can I learn from this? This representation. Okay. Well, if I look at the slope of this line right here, okay, remember slopes. This segment right here tells me my change in my position. I'm using the variable x for position. And this side tells me my change in my time. So remember, it goes, alright, there's the change in my position. Here's the change in my time. There we go. And so the slope of my position time graph, this slope of my position versus time graph tells me my velocity. Okay, so positive, so I have a positive slope, I have a positive velocity, and that means I am moving to the right. Obviously, if I had a negative slope, I would be moving to the left. Okay. What would that look like over here? Well, a positive velocity, again starting at 0, so the times would be the same. It would simply be a horizontal line moving at a constant velocity. Let's say that we turned around and started going back, so something like this, started coming back like that, then you would see that my velocity would be down here somewhere, and again would be a horizontal line. Okay, the slope of the line. All right. Now, the acceleration being the change in velocity, basically I have no acceleration, so this would just be 0, like that.